Okay, last example. Given the graph of f prime of x, sketch a possible graph of f of x. So now we're working backwards. We're given f prime of x. We need to find f of x. Show clearly the x values of any stationary points and points of inflection. Okay, so this is going to test your knowledge on this because we're really having to think here to go backwards. All right, let's think about what this looks like. Okay, so I have f prime of x, and I need to draw f of x. Okay. What tools can I use here? I notice here some interesting things about f prime of x. I notice that the zeros occur at 3 places. So I have at x equals -6 I have a 0, at x equals -1 I have a 0, and at x equals 5 I have a 0. Okay? If f prime of x is equal to 0, then what does that tell me about those x values at f of x, on f of x? Well, those x values correspond to the critical points of f of x, don't they? Okay, so these would be the critical points. Either they are going to be maxima, minima, or stationary points of inflection. Okay, so let's start by maybe investigating what the graph, the sign diagram of this would look like. Okay, what's the sign diagram of this? So I have -6, -1, and +5. Okay, here I have negative derivatives, so that means it's decreasing. Here, from here to here, it's positive. From here to here, it is negative. And from here to here, it is, oh, sorry, that should be a negative. Okay, and that should be a positive. Okay, so that really means that at -6, I have a, this is what my f of x would look like. F of x would look like this, because that's a minimum, right? Here to here, if it's positive, if it's increasing, then going down, okay, I'm going to have a maximum, and then I'm going to have a minimum as I go across this critical point. Okay, so at these points, I have 2 minima and 1 maximum. Okay, so let's go ahead and draw this. Now what's happening right here at 4 and what's happening right here at 3? Okay, well at this point the f double prime of x is equal to 0, right? Because the derivative of this function here, the rate of change of the tangent, or the slope of this tangent, which is f double prime of x, is going to be 0 here, and it's going to be 0 here. Now what does that tell me? That means it's a possible point of inflection, right? Well, it is a point of inflection if the f double prime of x is 0, but it's either going to be stationary or non-stationary, right? So is this going to be stationary or non-stationary? Well, it's not stationary because f prime of x is not 0, right? F prime of x is not 0. It's some number. It's down here, okay? It's not 0. So that means that we can conclude that it's going to be a non-stationary inflection point. Okay, and same thing with this one. Since f prime of x, yeah, the y value right here, f prime of x is not 0, this would also be a non-stationary inflection point. Okay, so let's graph this. Okay, I'm just going to do a quick sketch here. What's going to happen at 5? I'm going to have something interesting happening at 5. I'm going to have something interesting happening at -1. I'm going to have something interesting happening at -6. And I should have something interesting happening right here at 3. And something interesting happening at 4. Okay? So right at, let's see, at 4, what am I going to have? I'm going to have probably an inflection point. Okay? And at 3, I'm also going to have an inflection point. And those are going to be non-stationary, both of those. And here I said I'm going to have a maximum. Okay, so let's just arbitrarily draw some number there. Now this is for f of x, okay? This is for y equals f of x. So at negative 1 I have a maximum. At negative 6 I have a minimum. Okay? At 5 I have another minimum. Okay? And since it's increasing over here, you can expect it to be increasing something like that. Okay? Down here, I would expect it to be decreasing, so it should look something like this. Okay? Now what's happening at 4? Sorry, at negative 4. That should be a negative. At negative 4, we are going to see an inflection happen. Okay? So we're going to see a change in curvature. So where it's going to start increasing, and then it's going to change curves and come back down, like, and it's going to be concave up over here and then concave down over here. Okay, so let's see, where would be a good place to draw a point of inflection. Let's just say right about here. Okay, so it would look something like this, and then we would have a change in curvature. That's not very good. Okay, but you get the idea. It should probably look a little bit smoother, something like that. And then we would have another point of inflection right here. Okay, so you could draw anywhere over here a point of inflection, because this is a quick sketch. This is a possible. Okay, so this would look something like that, and this graph would probably look something like that. Okay, where that's a point. So here we have it. This is curve down, curve up over here. Okay, so we have the points of inflection. So that would be a rough sketch of what this graph, what a possible f of x would look like. Okay? All right.